The next big name in astronomy that we have to discuss is Galileo Galilee. I'll start with just the bullet points here, and we'll expand on this. Galileo was one of the first scientists to use a telescope to study the solar system. He peered up into the planets, looked at the stars, and see what he could discover. And Galileo's biggest claim was that he could grind his own lenses, make his own powerful telescopes, and he kept them very secretive. He'd only send telescopes that he'd made to people he trusted and respected the most, because anyone else who compromised, stole his telescope making ideas, could then be the new big discoverer. With his telescopes and with his inquisitive mind, he found the moons of Jupiter, and this is one of the final nails in the coffin of geocentrism. One of the core principles of a Earth-centered universe is that everything orbits Earth. But Galileo said, no, look, there are these moons. He only discovered 4 of them. We now know Jupiter has a lot more than that. But Galileo had definitive proof. If you could peer through his telescopes, you could see these moons now. You had enough resolution. And there must be these moons of Jupiter. These moons are orbiting Jupiter, not Earth. And so this is one of those final steps to getting rid of the geocentric ideas. Finally, he found the phases of Venus. And they should remind you of, say, phases of the moon. And there is no explanation of Venus's phases in a geocentric model. Can't happen. The only way for that to happen is if Venus is orbiting the sun. So finally, irrefutable evidence that you can see using a powerful telescope, you can finally definitively prove that, yes, this is a sun-centered solar system. So what are some other things that Galileo did? I have this comment here about breaking Aristotelian philosophy. There was this idea of what is the natural state of an object. And in Aristotelian philosophy, the natural state of an object is to be at rest, not moving, stationary. And Galileo said, that's not right. Things move. They have a concept that he started to call inertia. And things resist. Their inertia resists changes in their motions. And this is a subtle distinction, but it creates groundbreaking revolutions that our next person, Sir Isaac Newton, is going to take to extreme lengths to better understand the universe. Other things about Galileo, he's very much what we consider the first modern astronomer. He came up with these big ideas of trying to take measurements, do experiment. Your ideas have to be backed up with experimentation. He would do all sorts of crazy things, such as he noticed that pendulums, the time it takes for a pendulum, he was specifically looking at chandeliers in church, the time it takes them to swing around depended on the length and not the weight of the pendulums. No matter how massive they were, the time would be the same. It was always the length of these pendulums. And he measured this, I kid you not, by using his heartbeat as a clock. He would try and measure his pulse rate and count the number of beats between oscillations of the chandeliers. Well, obviously, those of you who have ever had the flutters when you saw someone that you were affectionate towards, you could tell that your heart rate changes based on external stimuli or even thoughts easily. So using your heart rate isn't the best tool. So he said, well, I can one-up this. He used the tempo of music. He would use music as a rudimentary clock to measure time periods. So Galileo was very much this experimentalist, and this pushes us closer and closer to what we call a modern scientist now, backing up your ideas with experiments. Speaking of experiments, Galileo came up with one of the ideas that all objects fall at the same rate. So let's bring me up here. Hello again. And I'll start with the simple tennis ball. And the idea is, hey, I throw the tennis ball up, and I see it fall down. And Galileo says, well, it doesn't matter if I'm using a tennis ball or a bowling ball. The rate, the acceleration of it falling down is going to be the same, regardless of what's falling. So let's convince ourselves of this. We're scientists, we're experimentalists. Let's test this out. All right, I'm going to sit here. I'm going to take a textbook and a piece of paper. And I'll argue, using Galileo's logic, that they must fall at the same rate. So I'll hold them out, let them go at the same time. I disproved Galileo. Okay, so obviously there's more at play here. There's air drag, friction, slowing down the paper as it's falling. So how can I convince you that they do fall at the same rate? Well, I'll put the paper underneath the book. That convince you? Yeah, I can hear some of the skeptical thoughts over the screen here. I was just letting the book push the paper down. So we do one more definitive test, right? I'll take my piece of paper and I will put it on top of the book. In this essence now, I have eliminated all the air friction, all the drag, and all I have is the two objects who are going to fall at the same rate. And there you have it. All objects, regardless of their mass, if they're heavy, or little light things, they all fall towards Earth at the same rate. And this is one of Galileo's great experimental discoveries. You can find pictures depicting him throwing rocks off of the Tower of Pisa. But, once again, all of this is trying to make conclusions backed up with evidence, backed up by experiments. That's a scientific principle, that you have to have an experiment to support your ideas. Some final comments about Galileo before we move on. I assume many of you have heard about the famous persecution of Galileo. Nevertheless, it still moves. And this goes back to a point in history where the church arrested and eventually sentenced Galileo to house arrest for the rest of his life. And some things I want to clarify about that time in history. Galileo's crimes wasn't explicitly interpreting the universe to be a sun-centered model, a heliocentric model. Yes, it's related. It factored into him being charged by the church, but his crimes were explicitly about interpretation of the Bible. At this point in time, the only people who are allowed to interpret the Bible are those who are ordained in the church members. And while Galileo was a religious man, he was not a theologian. And so, as he's publishing his findings, publishing his works, he's constantly wrinkling in there interpretations of Scripture, trying to understand the universe. And the church was very much displeased by this. Now, part of what protected Galileo for a long time for persecution was that Galileo's childhood best friend, the person that Galileo loved to hang out the most with as a child, was the current pope. So there is a lot more nuance and complexity than just the story of Galileo said it's an Earth-centered, it's a sun-centered solar system, therefore the church arrested him. There's more to it, but that is a nice summary. Moving on from Galileo, we have Sir Isaac Newton. The same year that Galileo passed away, Sir Isaac Newton is born. Isaac Newton discovers what is now our basis of what we call classical mechanics. He's discovering all these new laws. He's taking ideas that he's inherited from Kepler, from Galileo. He's taking all of that, and he comes up with these physical laws to explain the motion of not only the planets, not only the stars, but of everything here on Earth too. This is very different from Kepler's empirical science. Kepler said, I'm going to take numbers, understand, and pull out laws coming from them. Newton says, no, there is deeper meaning here. There are physical laws that will help us better understand the universe. So in our next video, we're going to describe Newton's 3 laws of motion.